Good afternoon, good morning for those of you on the West Coast. My name is Peter Buckley. I'm head of sales with Cambridge Technology, based in the Atlanta area. And welcome to our webinar on how to run and manage containers on AWS ECS. I'll give you a brief overview of who we are. I'll have a few things to say near the end of the presentation, but most of the presentation will be provided by Anil Dotre, our Senior Manager of Delivery. Next. About us a little bit. We've been in business since 1999. We started off in the application development and some migration work that we did, moving legacy mainframe applications to client servers. Over the years, we fast forwarded into cloud-based businesses, and we became a partner with Amazon's Web Services in November of 2009. We actually attended the first partner training program they held when they launched that program. We're an Amazon advanced tier partner, and again, we have been since 2009. We have about 450 employees located globally in India, the US, and Germany. In the United States, we have about 50. With offices in the Atlanta area, Charlotte, Louisville, Topeka, and San Diego. And we continue to provide services that I'll speak about a little bit more on the next slide. But in terms of certifications, we're CMMI Service Level 5 appraised, ISO 27001, 2013, ISO 20000, and again, we're an AWS Advanced Tier Partner. Go ahead, Anil. Next. This is a brief overview of our services, and as I said, we provide pretty much everything from an IT point of view. Again, anything in the application lifecycle, development, maintenance, acceleration of development cycles. We can migrate, transform applications, test, we do mobility, and we have a very robust DevOps practice. Again, we are engaged in cloud-based IT delivery. We can provide strategic cloud consulting. We've done transformations, migrations, SaaS development, proactive monitoring, and we provide 24/7 SLA-based managed services for any cloud environment, or for that matter, any environment. We provide anything in the big data, or what most people are calling data and analytics today, data warehouses, data lakes, descriptive and predictive analytics, and we can design your data lake or your data warehouse to give you better access to all the data that you're looking for. And anything on the AI side, machine learning, advisory solutions, and we even have a product that we call AI as a Service. But that briefly gives you an overview of who we are. Again, advanced tier Amazon partner. We have competencies in Oracle, DevOps, data and analytics, and we're also a certified audited member of Amazon's Managed Services Program. Next. These are some of the partners who we have engaged with over the years. Obviously, Amazon, ForgeRock for identity management, New Relic, Oracle, IBM Watson, Confluent, data streaming, Apika, Tableau, CA, and these are all technology partners we engage with because they enhance our services in regard to our customers' needs. And that's how we engage with technical partners as we move through this very quickly moving world of IT. At this point in time, I'm going to turn the presentation over to Anil Dotre. Anil, it's all yours. And I'll come back and speak to you near the end of the presentation. Once again, thanks for joining us, and I hope you get what you're looking for from this. There'll also be a time period at the end for Q&A, and thanks again for coming.
Thanks, Peter. Hi, everyone. This is Anil Dotre. I work as a senior manager for Cambridge Technology, and today I'll be talking about how to run and manage containers on AWS ECS. As part of the agenda, I'll be talking about the containers evolution, what AWS ECS is, what are the different offerings, the launch types, the design considerations for using ECS different launch types and the role of AWS ECR related to ECS and the different AWS integration points with ECS. And then I'll be talking about the best practices when we use ECS and with a case study, and then we'll do a quick recap. To start with the containers, right? So prior to containers, there was no standard packaging or shipping mechanism. So when I say packaging or shipping mechanism is that, if you have a Java application, you would have a Java file or a WAR file, and that it's not an end product by itself, right? You cannot just run that WAR file. You need to have the dependencies, you need to have the related environment set up even before you run it. And as any developer says, it works in my machine, it doesn't work in QA machine. So we had all these challenges. Now, the other part is also resource isolation, right? If you want to have different applications, different isolation, that was a problem. And part of it we can resolve is using VMs, but the challenge with VM is it is heavyweight. Reason being, it uses it has a complete copy of the OS, and since it's heavyweight, it's really time consuming to start and stop different VMs. That's where container comes into picture. So what exactly is a container? So container is a unit of software for basically you package all your application into one something called as an image, where you package the application, you all bundle all the dependencies and the environment, which makes it really portable, right? And it's lightweight. It doesn't really has the OS specific files. It leverages the host OS kernel, and it runs as an isolated process. So the runtime instance of an image is a container. So it is really lightweight because it doesn't have anything. It doesn't package any OS related files. Since it is lightweight, it is pretty fast. And since it is fast, you can scale in and scale out different instances of these containers. And since it is portable, you can run it anywhere as long as it's part of that distribution. And now that we have containers which are scalable, where you can run anywhere and they're lightweight, we will be creating different containers. And the challenge with that is, once we have these containers, now we have this whole thing of maintaining it. Like you need to have your own image repository. You need to manage the orchestration, the auto scaling, recovery, the networking, and the typical application maintenance, right? You need to have the monitoring and auditing. So these all things are part of the new evolution. Like you have the containers. Now you have to support all these different infrastructure activities. So that's where AWS ECS comes into picture. So as you see, AWS ECS is AWS managed container management system. So it works for Docker containers currently, but it is OCI compliant. But currently it offers only Docker. It has a 99.99% uptime SLA. It's a regional service. It's highly scalable and available. It runs on multi-AZ. ECS takes care of the orchestration. It also takes care of the cluster management, wherein you provision the servers and AWS ECS will manage it. And AWS ECS can also be run in a serverless mode, which I'll be talking in later slides. And as part of the feature, it has got CLI support as well as SDK, wherein you can start and stop clusters or tasks or services using CLI or SDK. I think as far as SDK is concerned, it has got most of the programming support like Java, Python, and Node.js. And you don't need to learn for a new language for managing the Docker in ECS. It leverages on Docker CLI support. So it supports Docker CLI. And then if you create a ECS cluster, you can import your custom AMI, or you can use the Amazon provided AMI, which is ECS optimized. The other important feature which ECS supports is dynamic porting, wherein you can have two different tasks with the same port number running in the same service. And I'll be talking more in the later slides how we achieve that. And then since ECS is part of the AWS ecosystem, it is integrated with a lot of already popular services, which includes load balancer and other services. I'll have more details in the coming slides as well. Now, how does ECS helps us? So as I mentioned, as far as infrastructure is concerned, you can just spin up and spin down ECS using CloudFormation. Basically, you have the whole infrastructure as code, and then it takes care of the orchestration, auto-scaling, and the security part as well. And then as far as the application is concerned, it provides you mechanism to discover different services. You can have networking between these containers, and then you can monitor and do auditing based on ECS. So the architecture of AWS ECS, it's a regional service. You first define a task, and then a task is where you define what are the different containers you'll be running as part of the task. And then if you have multiple tasks, you would just bundle that as part of the service. The service basically defines what are the different other parameters or the configuration you need running the task, like if there's any ALB or the load balancers, or if there's any placement strategies. All of these different configurations you would set up as a service. And then you can get containers. You can load the containers from different locations. You can use Amazon ECR, which is Elastic Container Repository, or you can get the container images from Docker Hub or your EC2 managed image repository. Now, on a high level, the hierarchy of AWS ECR is you create a cluster, and in that cluster, you can either run tasks on an ad hoc basis, or you can create a service which will manage all these tasks. And then more details on the cluster. So as you see, a cluster is a group of ECS instances, and then you create tasks or services as part of that. It is a regional service, and you use IAM policies to restrict it on who's going to use those like the different access control policy. So you define IAM policies as part of that. And I've put an image of a snapshot of how you define a cluster. You just define the cluster name, and then probably most of the time you would just use the VPC, which is already created as part of the project, or you can just create a new VPC. And you can tag each of these clusters based on the organization tags policy. Then once you create a cluster, you would create a service. So as I mentioned, service you can define as part of this service what task is going to run, and then you can define what is the different what type of service is this. I'll be talking more on the different types of the services, but primarily it is Fargate and ECS. The Fargate launch type is more of a serverless, and EC2 launch type is you define ECS cluster. So again, I'll be talking more on that in coming slides. And as part of the service, you defined the role if you would like to have the service run behind a load balancer, then you would define the deployment minimum and maximum configuration. So here we're talking of how much of tasks should be running all the time for new tasks. I have more slides as part of this. And what type of service is this? Whether it's a replica, which means it's a long running, or it's a daemon. And then we can also configure the placement constraints. Here, what I'm talking about is, when you create new tasks, it has to see in which particular instance it has to place, or if there's any task which is not performing well, what is the termination policy. Then you'll also define the networking. You'll be defining the auto scaling, how the tasks are going to scale, and then finally you'll be defining the resource tags. As part of the task, once you define the service, then you need to have the task in there. So a task it's like a wrapper for your container. A task is the basic unit of work. You define how much of memory and CPU you need for that task. You define what container is going to be part of this task. And then if there are any volumes attached to this container, then you can also define the different resource tags, the different IAM policy related to this tag, and the logging. And one note about the task containers is by design, container is meant to do one thing at a time, which means that it is designed for a particular use case. And that's what task is about. Typically, you would assign a single container to a task and run that task, primarily to scale in and scale out the tasks so that it can run at its own space. But you can attach more than one container to a task. There's a limit of 10. And these are the use cases where you would like to have more than one container running in the same ECS instance. And primarily, those are sidecar containers where, as an example, you have the application container, then you might have other service like logging container, which has to be run at the same instance along with other application. Then we talk about the launch modes. The first one is EC2 cluster. So EC2 cluster is a customer managed instance. So as you see the diagram, you define the task and the services, and these tasks and services run on the cluster which you create and manage. And the best part of this, the launch type is there's no charge. You pay for using this ECS. You are charged only for the EC2 instance which you create, and any other resources as part of that. The other option, which is relatively new, is AWS ECS Fargate. So this is the serverless option which I was talking about. In this option, the cluster, when you create a cluster, you don't really specify what is the instance type, or you don't define the EC2 instance information. All you define is you just define the cluster name, and you define what is like the configuration required as part of that. And this is a serverless model, and as you can see in the diagram, all you define is a task, and then any service if you want to have as part of that running those tasks. And this particular tasks, when they are created in runtime, they are associated with the ANI. So when you run AWS Fargate, it is typed to Amazon VPC networking mode. I'll be talking more in the later slides. But in the diagram, if you see, most of these tasks are running by, they run into AWS managed container instances. But of course, they will be attached to your VPC ANI for networking. The next common question is, now that you have two different tasks, you would have in what scenarios should I opt for EC2 cluster, and in what scenarios should I use Fargate? I mean, it's fancy to go serverless and use that, but there's few things you would consider before you decide which one to go with. To start with, ECS EC2 cluster launch type. So you would go for EC2 cluster launch type, if the application has got any compliance or governance requirement where you like to have more control on the EC2 instances. And the most important part is the costing as well. So you can leverage the AWS EC2 spot or reserve instances where you can get discount up to 30%, and use that EC2 instance to be a ECS containers instances. In this case, you would just install a ECS agent in your EC2 instances, and those will make these EC2 instances available for ECS. And the downside of this is it is managed by the customer, which means that you are responsible for updating the EC2 instances, the operating system updates, or the security updates. And as I mentioned earlier, there's no charge for using ECS in this case. You just pay for EC2 or its services. Compared to ECS Fargate, it is the serverless option which AWS provides. In this case, the customer, you can just focus on application logic. There's no cluster management here. You just configure and run containers. AWS is responsible for updating the operating system and all the related security patches on which the container is run. And you pay per task here. It's priced per task. Pricing, I have a separate slide coming. And the next one is, as part of the service configuration, this slide talks about auto scaling. So, as part of auto scaling, you would define what is the minimum number of tasks which should be running. the desired number of tasks which should be running all the time, and what is the max number of tasks. So as part of that, the first autoscaling type is target autoscaling. So here, all you say to ECS is, I would like to have all the time. You can configure like the average CPU should be this much, or the memory should be this much, or if you configure ALB, if you hit a target count of these many number, you scale out or scale in. So this is a, I would say, if you don't want to really configure your own CloudWatch alarms, you can just leverage on target tracking, and it does that job for you. So this is a new update or upgrade to ECS. It was launched just last year. And there's other autoscale type, which is step autoscaling. So this one is more you managing all of the scaling by leveraging Cloud Alarm for scaling purpose. So you can define the scaling in and out based on CPU utilization or memory utilization. So you can configure if the CPU hits, let's say 70%, then you scale up. And then you can also set up, scale down operation if it is less than 30, then you scale down. So that is the best part of the auto scaling. And the next part is, once you have this service setup, you would be you'll be having, what type of service is it? Is it like a long running service or a short running service? So there are two types here. It's a replica and daemon. In replica, these tasks are it's more for application, wherein it's running on a long term. You just define the number of tasks you should be running, and ECS will take care of rescheduling the task if it is failed or interrupted. Versus the daemon stuff, which is daemon type, where it is primarily for a batch or a single run services. It deploys only one task, and then it's only available for EC2 cluster. So you cannot use daemon type for Fargate. So you would go for replica, or you would not even create a service. You can just create a task with a service and run that as a standalone thing, if you have to use for a serverless Fargate. And then this slide talks about the placement strategies. Placement strategies, where in simple words, it's like ECS will use algorithm for task placement, right? For new tasks or for tasks which are not performing well, what is the algorithm it has to use to add or remove tasks? So you can configure this when the task is running or when you create a service. So these are the different strategies. So the first one is random, wherein ECS will randomly place or remove tasks from your cluster. And the second one is spread based. Here we're talking of the ECS instance being evenly spread based on EC2 instances. You can also say, you spread based on EC2 instances, as well as once you have per AZ, you can define, you spread it based on the instance type. And the next one is bin pack. So bin pack is where you would like to run as many tasks as you want in one particular instance, then spreading it across. So if you see here, you have use cases where you don't want to have a lot of cluster instances. It could be for cost or for different reasons, and you want to package as many as tasks in one particular instance. In that case, you would use a bin pack. So what ECS does is it checks for the least amount of CPU or memory available, and if the task can accommodate in that, it will just run it there. And in this strategy, if you see, the spread is where you're spreading more and more tasks, in different containers, and the other on bin pack it's more of the inverse of it. So you're trying to put more and more tasks in one location, and of course there are like trade-offs for each of these. The first one being more highly available, then the later being less available because it's more, it's not running into different instances. Again, it depends on the application design or the requirement, how you want to go with that. Then we'll be talking about the deployment options. So in this case, we have like two options. The first one is rolling update. So rolling update is managed by ECS. So here we're talking of a scenario where you created a new version of the container and you would like ECS to deploy it. So in this case, what as part of the configuration, you would be required either to configure a minimum healthy percent or a maximum percent. So here what we are talking about is when you say minimum healthy percent, you would, let's say as an example, you would configure that you're okay with having minimum health of 75%, and you have configured that the desired task count is 8, which means that you're okay to scale down 2 tasks, and then those 2 tasks are replaced with the new version of the task. That's how this minimum health percent works. Compared to maximum percent, here it's not about here we are just talking about what is the scale out percentage ECS can go for. So in this case, what happens is if you configure the desired amount of task is like 8, with the maximum percent you configure as 150, which means that ECS can add 50% more of your configured tasks and then replace the old ones with the new ones. So here as an example, if you configure a task with 8 with the maximum percent 150, it means that the scheduler can add up to 4 tasks at a time, which means that it's going to take 2 iterations for it to change all the old instances with the new one, compared to the previous minimum health percentage where it takes, I think, 4 iterations. So if I have to put it in simple words, the minimum health percentage is like the ECS would initially scale down the number of tasks and then scale up with the new tasks. I would just think that way. And the other one is the maximum percentage, where basically it will keep the old instances but add up new instances, scale up the new instances, new task with the new container type, and then scale down the old ones. So that is the easy way for me to think these 2 different types of percentages. And the other one is more on DevOps practice, or it's more on having using AWS DevOps or CI/CD operation. So in this operation, you would have 2 different deployment setup, that is blue green. You would leverage AWS Code Deploy. So here when we talk about blue green is where you have one production instance running, and then you would create a parallel ECS environment where it's having all the new containers running. So you would just switch from blue to green once you confirm that everything is good. So that's why the deployment type here, if you go with this option, you have only one option, whether to deploy all at once. And then as far as routing is concerned, you can configure 2 types of routing, where if you have a robust CI/CD process, you can say automatic rerouting, where you have robust or reliable test cases doing complete automation testing. Then once the new deployment comes, it automatically routes the traffic to that. Or if you're an organization who has just started doing this DevOps practice, or they're in the process of having robust test cases, in that case you would have more of a manual routing. You would just create a new green deployment, and then you test those green deployment setup, and if it looks good, then you change the routing from blue to green, and green eventually becomes the blue. And then you can also, as part of this deployment, you can configure whether you want to retain the original instances or you want to terminate. But again, it depends on the strategy. Retaining the old instances is more for doing a rollback. If for some reason the new deployment is not doing good, if there are any problems, you can just go back to the old instances, then spinning up the old instances with the previous container type. So this slide talks about task networking. So Docker ECS supports most of the Docker container types, networking types, including bridge, host, and there's additional the new networking type, that is AWS VPC. So as you're aware, bridge is the default Docker networking type in ECS as well. And the none is where you would configure a task which doesn't need any networking, which means that it doesn't need any communication outside of the container. And host is where you leverage the host network on which the container is running. The last one is where it integrates the AWS networking VPC. And as part of this, every task will be assigned the ENI network based on the VPC configurations. And as you see, there's an asterisk next to each of the host and the AWS VPC. Basically, what it says is, since we are leveraging on AWS networking, it is high performant. And then the only down part of that is you cannot really use dynamic porting. Reason being, it uses the host networking. And AWS VPC is the only option for Fargate. You will not be able to configure bridge, none, or host as part of the networking. More on dynamic porting in the coming slide. In this slide, we'll be talking about volumes. So as far as Fargate launch mode, Fargate is primarily designed to be stateless. As designed, you would be leveraging more on S3 or for storage purpose, but still for ephemeral storage, you'll be given 10 gigabytes of storage data, but this is non-persistent, which means that you cannot store it for a long time. Once the container is being terminated, the space is removed as well. And you get 4 gigabyte for volume mount. This is primarily for sharing among containers. So in this launch type, as I said, it's more of a stateless thing. And the other one is the other launch type, which is EC2 cluster. It provides two types of volumes. One is the volume type itself as a volume, and then the bind mounts. These are primarily based on Docker. So volume type leverages on Docker volume types. It is mounted at root var lib Docker volumes location. You can use a third-party driver to access this volume. Like you can this as a volume type using a third-party driver, or you can use the bind mounts, where it just binds a file or a directory of the host machine to the container. Again, there are a lot of dependencies on each of these, when to go with the volume type versus to go with the mount type, bind mount type. And the next slide, we are talking of resource tagging. So in this case, primarily, first thing is have each of the resource created in ECS, which includes task definition, cluster, task services, and container instances. Each of these get Amazon resource name. So what it means is that you can use this ARN as part of access control. You can use this for auditing. You can just do a search for a particular ARN into, for example, CloudTrail, and see who created it, when it got created, or who deleted it, and when it was deleted. Or you can use the ARN to restrict, this particular cluster can be accessed only by this particular role or these set of users. And the most important part of resource tagging is you can use it for your, for costing purpose, or for or you can leverage AWS Config Manager to make sure each of these resources are having certain organization standards. Like you would like to have every task definition having a name, who created it, and all that. And as far as pricing is concerned, I mentioned, I think, a couple of times, the best part of EC2 cluster type is it's free. You don't have to pay anything. You just pay for EC2 EBS resource utilization. And for Fargate, you pay per task. So it is charged per CPU and memory resources per second and per task. So per CPU per hour, it is 0.04 cents, and per gigabyte it is 0.004 cents. Again, these are priced as of 4/3/2019. These prices fluctuate, as you're aware, but we have just kept it here for your reference. And these are As far as the combinations are concerned, you can configure a task. If it is a simple small task, you can configure that it's going to run. It's going to take 0.25 CPU with a range of 0.5 gigabyte to 1 or 2 gigabytes. Versus if you have a task which is more CPU intrinsic or it needs a lot of memory, you can configure as big as it needs 4 CPUs with a maximum of 30 gigabyte memory. Again, it starts with 8 gigabytes with an increment of 1 gigabyte, which means that you can go anywhere from 8, 9 till 30 gigabyte. And the price is the example which I've given is for US East Ohio. You can get more details on AWS ECS pricing page for different regions. And then this slide, I'll be talking about ECR. So what exactly is ECR? ECR is the managed container repository which AWS provides. Basically, it is an easy way for developers to store, manage, and deploy Docker images. If the organization is having its private repository and most of it is already having AWS ecosystem or services leveraged, the organization can now use ECR and use ECR to manage all the containers and then integrate with ECS for creating them. You can leverage on AWS IAM to access the different containers. And since it's more of a managed service, it is more reliable, scalable. It removes you the overhead of managing the container image repository. If all the time, as part of the server maintenance, you don't need to worry about the memory or the space, which outgoes over the time. It is integrated with ECS, and then the best part is you don't need to learn a new language or a new specification to manage the container images. It leverages on the Docker CLI, which means that the command which you're already using, for example, to list the containers, list the images, or to push and pull the images, you can just use the same CLI to manage that. And it is priced 10 cents per month per gigabyte, with of course additional charge for transfer out of data. So if there's no data, if you're using the ECR with ECS within the same region, then there's no transfer charge. The pricing is based on 4/3/2019 for US East region. The pricing changes for every region, and for it's basically time-based. So the next slide, I'll be talking about the different AWS services integration. This is the best part, right? So you can run the containers, and now as part of running the containers, you need to have a lot of other infrastructure services like security, networking, costing, logging, auditing, monitoring. So you can leverage on AWS services. For security, you can use AWS IAM, where you can create users, roles, groups, and assign them relevant permissions. And then you can leverage on AWS security groups. It's more or less like a firewall where you configure who is authorized. I've not mentioned here, but you can also leverage on NACL, which is again the second tier for protection. And then if you're using ALBs, then you can combine that with AWS WAF, Web Application Firewall, and then the AWS Shield as well. So Shield is a service where it takes care of the DDoS and all typical web related threats. And then networking, you can leverage AWS networking for creating the you can integrate VPC, and then from the VPC it creates the ENI elastic network interfaces for each of the tasks. And then you can leverage the multi-AZ feature for high availability. For costing, which is pretty important, you can leverage the Cost Explorer as well as budget, wherein you can see exactly for which service how much you're paying, and you can set up budget alerts. So ECS is integrated with costing as well. And for the discovery, when I say discovery here, every application, if you have different web services, REST services, and the back end and front end, instead of hard coding the configuration into config files or any other place, you can leverage on the AWS Route 53 or the newly recent Cloud Map feature. So the AWS Cloud Map is a new service where you can have logical names for each of the Amazon resources, and as part of that, the application developer will not be concerned anymore for if those resources are scaled down or scaled up, and if there's any change in the names of that. So Cloud Map helps you give logical names, and you can use these names in your application then depending on the ARN or other names. So it's a relatively new service created, but yeah, as part of Cloud Map, you can use DNS, or you can use different names there. And for it primarily uses Cloud 53 private namespace to manage this. And then high availability is based on using ALBs and multi-AZ subnets. So you can deploy your application into different AZs and then load balance them using ALB. And then you can also leverage AWS DevOps practices, where I think I already mentioned you can use code deploy and code pipeline as part of CI/CD, as well as code build. Where you first do the, as part of the code bid, you would get the source from Bitbucket, or in fact, you can use AWS CodeStar to get the source, and then create containers using Maven or any other build tool. And then once the containers are created, you can create a pipeline to deploy them into ECS. You can leverage on AWS logging as well. And you would, as far as logging is concerned, CloudWatch logs are used. You would create different log groups for each of the tasks and do the monitoring. I mean, as part of this solution, you could use AWS Elasticsearch and leverage the Elk stack, which is log stacks and Kibana, and do visualization for the logs. And then for auditing, you would leverage CloudTrail. CloudTrail is where you can go through the different like who accessed which service and those details. And for monitoring, you can leverage CloudStack metrics, CloudWatch metrics, wherein you can see for ECS what are the different like how much of CPU has been utilized and how much of memory for each of that. And then we'll be talking about best practices. As far as design is concerned, as I mentioned, a task is designed to run one container at a time, unless you have containers which have to be run in the same instance. Typically, those containers are sidecar containers. And the primary reason for doing that is scaling and for deployment tasks. You don't want to bundle different tasks which are not related in the same different containers which are not related to be in the same task. Reason being, it again leads to a point where you're just putting all different things in one bucket, and changing one bucket, changing one task or one container would have unrelated effect to the other one. And then I would leverage on auto scaling to make sure the tasks are running as desired with desired count, and I would go for AWS CloudWatch with alarm. So if anything is wrong with the containers, it would just send notifications. And as far as caustic is concerned, if you are going with the EC2 cluster type, you would you should be leveraging on spot instances. Reason being, spot instances with broad instance types. So what I mean here is, when you configure a spot instance, you would say, you're okay with M3 or M5, you're okay with 3.3. I would put as many as instance types, as I can, so that it will be more or less sure that you would get a spot instance rather than just specifying one instance type. And then you would leverage auto scaling, especially for scale in option. Most of the configurations they are more of on scale out, but I would be more looking at the scale in options as well, so that in peaks it scales out, but once the peak is down, you want to make sure the scale resources are scaled in. And security is the important thing. I would leverage on IAM policies. I would have the least privileged access control model to make sure the tasks are only having the required access for them than just giving all access. I would reduce the surface attack, wherein I would not open unrelated ports or any other you know, opening of any other service. And then by default, when you create a container, it runs as a root. So I would not do that. I would create a non-system or non-root user and then use that user when inside the container. And then I would leverage on secrets to secrets are for any confidential information. It could be a database connection or any other information which is confidential. Instead of embedding that into the image or getting that from a file which is as part of the system, I would rather leverage on secrets and embed that into the system so that everything is confidential. And then finally, I'll be talking about a case study wherein we had as this is one of the different solutions CTS has resolved or designed and developed. So in this scenario, the client had large amount of scientific data and till the time this data was huge. The criteria was they wanted the data to be available for the scientists as soon as possible so that they can do data analytics. So it would take any time from three weeks to a month for processing the data, and then with the limited resource and network bandwidth and based on the volume of the data, that was a challenge for the client, and they wanted a web application for data analytics. And as part of one of the solutions CTE provided, we developed all of the solution in AWS. We leveraged on serverless application powered by Lambda and Fargate. And this was primarily for compute purpose. And then we also used ECS EC2 cluster for the long running task. And we leveraged on microservice architecture where each of these different business use cases were by themselves. The solution was cost effective, reason being the high volume components were more on demand, which means that they were not running for a long time, they were short lived. And then we applied different access controls for each of these components so that they are secure. And then we also leverage on AWS S3 lifecycle policies to make sure we don't pay for storage over the time. As you see the architecture diagram, the flow was the vendor copies the data from the vendor bucket to the client bucket, and we used event-based architecture where once the data is in the client bucket, it calls a Lambda function which creates on-demand EC2 cluster based on Fargate, and then it just computes that and stores that into a S3 bucket. And then as far as the web application is concerned, we had Docker containers with different tasks for the different tiers. And then we leveraged on ALB to load balance them, of course, using ECS service. And then we also leverage on Athena for doing the query on the data which is stored in S3. And again, this architecture is more emphasizing ECS. There are a lot of other components. We didn't want to complicate or put a lot of more information when the focus is more on ECS. And a quick recap, we spoke about the features, architecture, task, and service definitions. We also spoke about the launch types, the integration. And I will summarize the new features, which was last year, as part of the ECS release. The new one of the critical, I think, features were allowing Docker Compose, where you can club many containers as one particular compose service. Target tracking, which I already explained, and then the health checks and as you see, they are daemon scheduling and SSM parameter support, which is the secrets, and then you can configure the temp size, the app mesh, the new service where you can the different microservices can be integrated with app mesh instead of having a string of or a tangled services. Then it also supports more faster time. And if you have any questions on container strategy or consultation, please contact sales@CTPL for free consultation, and we'll be glad to help you. And I would hand over it to Peter for the next steps. Thank you.
Thanks, Anil. That was great. I just wanted to add that, and thank you again all for coming. Try not to hold you. There is a question or two that Anil will get to here in a second. But remind you that we are an Amazon Advanced Tier partner as such. There are funds available for POCs and other projects around ECS. And if you'd like to leverage the resources, all the resources of Cambridge Technology and Amazon, please give us a call. My contact information is listed below, and we'll send that out after the webinar. We'll also send you a link to review the webinar once again, if you'd like to, or pass it along to colleagues in your organizations. Again, thank you very much for coming. Anil, I think there's a question or two. Would you like to take those?
Yeah, sure. So,
The one that I see, I can do this for you.
yeah, I'm just looking at.
How do you configure auto scaling of containers? Is it based on thresholds set on memory and CPU of the container?
Yes, yeah, I was just trying to scroll through this question. Yeah, so as far as the auto scaling is concerned, you would do that as part of the service configuration. So when you create the service, you would define whether to scale based on memory or CPU or both. So basically, the answer is when you configure the service, you would that's where you define how many like what is your auto scaling set. So is there any questions?
I think that's it. Well, once again, thank you very much for joining us. I hope we answered most of your questions. Again, if you have a project that's planned or in process and you'd like some help or be able to leverage some of the resources of Cambridge and Amazon together, please give us a call. We'll reach out to you with a link for the webinar once it's completed in the next day or so. Have a great weekend and hope to see you at another webinar soon.